This is the third video of the National 5 topic of similarity, and in this video we'll be looking at calculations with similar shapes. So really tying together things we've been looking at in the last two lessons. Scale factors can help us calculate unknown lengths, as we've seen before. Remember to take care to leave your scale factor as a fraction rather than a decimal, as it's often easier to work with. And then, for example, for each pair of similar shapes, calculate the missing dimensions. So looking at this shape here, I've got A, and at the two shapes over here, there's an X there, and I've got a second missing dimension, a Y. And I would need to, before I find a missing dimension, I would need to calculate my scale factor. So I've got this idea of finding corresponding sides. Look, I know the bottom, the shortest side of these two rectangles. So that will help me put together my scale factor of enlargement, because the A is on the larger of the two. Worth just looking, a little bit of notation here. I've got scale factor E, an enlargement scale factor. Small e just detailing that. So how many times does my 3 go into my 9? I'll write that as 9 over 3. Well, it goes in 3 times. Got a scale factor of 3. Now look, I'm trying to find side A. He corresponds with 5.5. So I need to take that 5.5 and I need to multiply it by my scale factor of 3. Either mentally or doing a little bit of work at the side of your page. That would give you 16.5 centimeters. The second pair of shapes, again, it's got two missing values. It's got the X over here and it's got the Y on the larger of the two. So if I was to concentrate on X first, who's on the smaller of the two shapes, I would need to find my scale factor of reduction, looking for the scale factor that would shrink it. Now, if you remember, scale factor of greater than 1 would enlarge a shape. So here I'm looking for a scale factor less than 1. Corresponding sides. I know these two sides down here. So I've got a pair of corresponding sides with numbers on them. So my scale factor is going to be 3 over 6.6. But the smaller of the two values on top, because I'm finding the reduction scale factor. Again, fairly tricky to simplify in this format. But if I times the top and bottom by 10 here, that'll give me 30 over 66. And, well, I can see both of those are in the 6 times table, so I could divide them by 6 to give me 5 over 11. Now, I would recommend leaving that as 5 over 11. Well, it's much easier to work with a fraction than multiply by whatever this would come out as a decimal. So, to find x, I look at side x, I find this corresponding value. Now we need to multiply that by my scale factor. So I've taken 8.8 and I've multiplied it by my scale factor. A few ways to do this. Looking at the numbers involved, 8.8 times 5 isn't that tough. So that would give me, well, 4.4 over 11. Again, I've prepped this in advance. All I'd be doing, a little bit of work at the side of my page. 8 times 5 is 40. 8 times 5 is 40. And the 4 I've carried over. It gives me 44.0. Then I'm left with 44 over 11. Well, that just goes in 4 times. So x is a value of 4 meters. If I'm left trying to find y, notice y is on the larger. It's on the enlargement. So I need to find the scale factor of enlargement here. Again, using my two corresponding sides, I could put my scale factor together. Again, wouldn't want to simplify in this format. With these decimals, times by 10 to give me 66 over 30. Then, well, I could divide by 6 to give me 11 over 5. Again, notice my scale factor for reduction and my scale factor for enlargement, they're the same thing, just one's been flipped. That's something we might have a look at in a later video. I want to find y. So I look at y. I find his corresponding side. So I know this 2 meters will need to get multiplied by my scale factor. So I've taken my 2 meters and I'm multiplying it by my new scale factor, my scale factor for enlargement. 2 times 11, give me 22 on top, over 5. Again, depending on how good your number work is, you might be able to get that. Failing this, you could say, oh, how many 5s are in 22? Goes in 4 times. Remainder of 2 goes in 4 times. Which gives me, ooh, a typo there. 4.2. It should read 4.4. So apologies there, folks. Okay. Slightly different question. We've got this idea of a model car is 1/6 life size. Okay, so it's 1/6 the size of a real life car. So this is a nice example of a similar shape question where it doesn't actually mention similar shapes. When you think about it, a model of a car is just a shrunk down version of the full size one. Now we've got a couple of questions. So first part, a real tyre has a diameter of 720 millimeters. What is the diameter of the tyre on the model? Second question tells us the rear wheel has 20 equally spaced spokes. What is the size of the angle between spokes on 1, the real car, and 2, the model? So, dealing with first part, we've got scale factor of reduction. The model is going to be smaller, so it's been reduced by a factor of 1/6. So, the diameter of the model car is going to be the diameter of the real tyre multiplied by my scale factor. So again, notice I've not made these numbers up. 720s come from the real tyre. The 1/6, well, that's my scale factor. Multiplying by a sixth is just asking you to do a division, really. How many times does 6 go into 720? You can be doing a wee division sum, but 6 goes into 72 12 times. So it goes into 720, 120 times, giving us a diameter of 120 millimeters. Second part, asking us to think about the angles. There's 20 equally spaced spokes, so the word equally is important there. It basically means the full circle of the wheel has been divided into 20 equal parts. So the angle on the real wheel between the spokes is going to be 360 divided by 20. Writing it as a fraction, just to show, well, we can cancel out by dividing by 10. 2 goes into 36. 18 times, meaning it's a space of 18 degrees. Not really a trick question. The angle between the spokes on the model is also going to be 18 degrees. What we need to remember is similar shapes change the lengths of the sides, but the sizes of our angles remain the same.